Hi folks, so I'm just, I've got all my data here and oh, I noticed that I haven't put my lines in. I had to redraw my data table. Oh no, I'm going to have to do a squiggly line. I had to redraw my data table because I did not have enough room for my 5 sig fig frequency data. So I redrew my table very quickly. There we go. So I'm just doing my means here, and it's a good time to point out how we've got to be very careful with our sig figs. So my first mean, my calculator has given me a 6 sig fig answer, and I've got to make sure that I don't just take all that data because I want it. I feel that, oh, my calculator's told me this is what the answer is. That is definitely the accurate answer. I want to put all those numbers down. You simply cannot. Okay, your precision must match your data. 5 sig figs, 5 sig figs. If you've still to do your means and random uncertainties, now would be a good time to pause the video and make sure that your table is fully complete. So there we are with all our means. Just move my actual bottle over there. And so now I start on my random uncertainties. So looking at our first line here, my maximum number is 150.2, so that's 150.2 minus my minimum number 148.12 divided by 5 equals that. Okay, so single sig fig, that is 0.4. Now this is interesting because my random uncertainty is now to a lesser degree of precision than my mean. So when I write down my mean, or when I use my mean from this point on, I will need to round off the mean. So that mean will have to become 149.4. And I might actually put another little column of means and random uncertainties underneath where I show that I've done that. Okay, so carrying on. And I think it probably is quite right that that our means aren't to 2 decimal places, because there's a large degree of variation in these repeats, and so I really don't think I was really recording frequencies to this level, to a hundredth of a hertz, considering the method that I was using. Okay, so here you can see, guys, I've just rewritten my final volume and frequency data. These are my average frequencies with their random uncertainties. There's no need for you to do this, but I just want you to highlight the fact that because our random uncertainties are to only a single decimal place, if we were to ever use these mean values going forward, so for example in a graph, which we'll have a look at next, we really need to round those values off to match the uncertainty. Okay, so what we're going to do with this data is we're going to learn how to pop it into Google Sheets and produce a graph quickly and easily. I know a lot of people get quite intimidated by using spreadsheets and producing graphs, but I'm going to give you a method that will always see you producing a high quality, full marked graph for higher and even advanced higher, and you can always go back and kind of run this tutorial through at your own pace whenever you're doing a graph in the future. And it really is an essential skill nowadays. There are very few jobs out there that won't want you to be proficient in spreadsheets in some way. I had no idea when I entered teaching just how much I was going to have to use spreadsheets and how familiar I was going to need to get with it. And so this is a skill not just for higher physics, but for life generally nowadays. So I'll see you in the next video for an online tutorial. Thanks very much.